Okay, well, I've just spent 2 hours trying to unbreak something that I sort of broke. I I used to be able to mirror my Android device onto the screen here, and I thought that would be a nice thing to do, is to kind of go back and forth between that and Desmos. Unfortunately, when I upgraded, it seemed to make everything quit working. Um, and so I've sent an email to the company, but uh, I'm stuck here. I'm going to use Desmos to look at uh, some of the homework problems here. May end up using the Android to look at some others. But the reason I want to use Desmos is, for instance, if we look at section 1.2 homework, so I'm going to add a note here, and so I'll say section 1.2, like that, and I'm going to add another note that says, hey, this is number 2. And in this case, what they'd like us to do is find the limit. So I have to look over here to see what it is. The limit is x goes to 3 of x minus 3 over x squared minus 9. So f of x equals x minus 3 divided by x, where is it? There it is, x squared minus 9. And we want to know the limit as x goes to 3. Okay, so that's over here. There's 3. And it says, this is kind of nice, see, it says it's undefined. Well, yeah, it's undefined because if I put 3 in here, I'll get 0 on the bottom. But the nice thing about this Desmos is I can do something like that, and yep, there it says undefined. And what they want us to do for this problem is simply fill out a table. Well, that's also kind of nice because I can go here and say, enter a table. And now I have x1 and y1. We're going to fix the y1. The x1 I would leave as x1. But here, if I highlight and I say f of x, 1, then it should start filling everything in, and it says, okay, start at 2.9, go up, add 9s at the decimal place, and then 3.001 and so forth. So I have 2.9. Now, wasn't that nice how quickly that calculated? Here, let me make this just a little bit bigger, and whoops, not that, this over here. And also, I suppose I could go to projector mode, and so that makes that easier to see, and I can do 2.99, 2.999. So this is one of the great things about this Desmos calculator is, I can define it symbolically up here and then just make this table like this, and I don't have to keep punching it into a calculator. Now 3, of course, if we put in 3, it says undefined, but then we look at 3.001, which they asked for, 3.01, and 3.1. And so there I have the numbers, and by the looks of it, what appears to happen is this looks like it's probably going to 0.16666, so 0.16 with the 6 repeating. And we could always check that. I could go in here and add another 9, 2.9999. Yeah, it seems to, right, it just seems to keep moving that 6 over, adding another 6, and then everything else looks kind of the same. And I could go in here and do the same thing. And what's nice is with this technology, it is that quick, right? And so I can see it looks like numerically then I would say that this limit is 0.16666, so what the heck is that? That's 1/6. Now the other thing we can do is realize that this, so I'm going to come back up here and say, well, this is no different than if I factor, I have x minus 3 divided by x minus 3 times x plus 3. And see, if you don't believe me, well, look, they're sitting right on top of each other. So I factored that, and so really this is just 1 over x plus 3, but 1 over x plus 3 is just 1/6. Now actually there is, oops, I'm not sure I wanted to do this. I'm trying to remember 0.1. Oh yeah, there it is. Okay, so suppose I do, oops, I went too far. Let me come back. There. So that shows a fraction, so let me see what happens. Oh, see, not so great. That's very close to 1/6, but we can't really tell that. And as I go in like this, 4 over 25 and all that, and so the fraction thing didn't work so well. I was hoping it would be magical and just show us 1/6. Unfortunately, it does not. But anyway, so we can see this. We can do that factoring and see that we get 1 over x plus 3. And so if x is going to 3, then this should look a lot like 1/6, which this does. And now another way to get an idea that this might be about 1/6 would be to take something like 1 over, take the reciprocal of this and see what you get. 1 over and then 0.1666, and notice that you see it starts looking like 6. And similarly, what are some other fractions I know, like 0.325? Is that what I wanted? 0.325, 1 over I don't know. That's the problem with trying to do things on the fly, but let's do that. 325, 13 over 40. Now that is exact, so that wasn't quite, oh, I think I want 3125. Yeah, there we go. 5/16. That's a, something that maybe I see once in a while, or 16ths, and that's because I do a lot of woodworking and so forth. So 0.3125, is 5/16. So the fraction can work nicely. Unfortunately, it did not up here. So, okay, but we've got that, and we could say on on our homework paper, we could easily copy all this down, right? So what a nice tool this is. And so all our numerical work, we can do the same sort of thing, and we can try to see what we have here. And so that was number 2. Let me go to number 6, which is cosine of x minus 1 over x. Okay, so I'm going to change that to number 6, and it is cosine x minus 1. Now I'll highlight this and then hit a slash for division. Other way, I could, as I did here, you could use parentheses. And x, like that, get rid of this, get rid of that right now. Now, in number 6, they want us to go minus 0.1 and then minus 0.01, and so I can do the same sort of thing here, minus 0.1, so we want to look at the limit as it goes to 0, minus 0.01, fix this one up here, minus 0.001, I'll put in a 0 here, undefined of course, and then here do my 0.001. We get some nice symmetry here. Now this is positive, that's negative. 0.01 and 0.1, and I'll get rid of the rest of this somehow. There we go. Now, as I look at this, so this is times 10 to the negative 4th. It looks like that's heading to 0 and that's heading to 0. And the nice part here is I've got a nice graph. And so I can look at this graph and see that, yeah, that looks like it's heading to 0. I can zoom in here. And notice these blue dots, they are from the table. And so I can zoom in and see what's going on. Of course, this is undefined, but as I come in here, yeah, it looks like that's definitely going to 0. So the graph along with the table helps me see that. Now, if I only had the table, again, I could kind of see that appears to be what's happening as I put these numbers in. And again, I could put numbers closer and closer to 0 in here for my x1. But, I can copy these down and say, oh yeah, I think the answer is 0. Great. So that's working on, those first few. Then what it says in exercises 7 through 14, create a table, right? So if I'm looking at, say, something like number 10, it says to create the table. Well, no big deal, I can do that. So, excuse me. Number 10 is x cubed plus 7, plus 27 over x plus 3. So I'm just going to go in here and, oops. So x cubed plus 27 and over x plus 3, and I'll zoom out to try to find my picture here somewhere. Oh, I turned it off. So, there it is. And now I have a bunch of points here, but I'm interested in this case, the limit in number 10 is going to negative 3. And, so this is minus 3, which undefined. And here I want something a little more negative, and so I'll just put a 3 in front of that, a 3 in front of that, and a 3 in front of that. And here I want something a little more positive, so Now, I don't know if I can do math within here, so suppose I did the -3 and plus. It's happy as a clam. How about that? And, I could do the same sort of thing, or I could put in my minus 2.999, and then here minus 2.99, and finally minus 2.9. And as I look at those, it seems like these are heading toward 27, these are heading toward 27. So life is wonderful. I can use that table and declare my answer to be 27. I can also go over here and zoom in. Oh wait, -3. I was looking at +3. Look here at -3, and of course zooming in on the graph, there's y equals 27, and that certainly looks like we are heading toward a value of 27 here for -3. These are kind of hard to see down here, but there's -2, there's -4, so that is the -3 line. Okay, so that was number 10. Then finding the limit graphically. And what I'd like to do here is point out that we can enter, so we see the graphic part, so if I don't have the table, I get rid of the table. I can still look, and I can slide this along and see what's happening. Once I hit -3, it should go undefined. I saw it there for a moment. There we go. Undefined. It even puts a little open circle there for me, and then I keep going like this. So if I'm coming down this way, it looks like it's heading toward 27. Then all of a sudden undefined, and I'm a little below 27. And if I'm coming up this way, a little below 27, I finally hit 27. So any of those graphically. But let's take a look at number 18. Okay, because 18 is a piecewise defined function. And it's just asking, does the limit exist? Well, I want to put that function in here, so I want to get rid of that. Now, to do a piecewise defined function, the main thing to remember is mostly we just have to do it in the opposite order of how we tend to write it. So there's my wavy curly brace, just like if I look at number 18, that's what it has. And then I do my first condition. Well, and it's x squared plus 3, so x squared plus 3. But the thing is, I actually have to, and then I would want to put the condition, but we actually put the condition here first. So I have x not equal to 1. So let's see if I can do that. I don't know that I've ever tried a not equal. Not equal. No. I'm just experimenting. Now, I can always go here and look to see, so here are some symbols. I see greater than or equal and so forth. I see braces. I'm hiding some things there, but there's no not equal sign there. So I go back to the numbers. There's equal. Nope, I don't see anything there. And so, okay, how do we do that then? Well, not equal to is both less than and greater than. So how about, what is it, not equal to 1? And so I'll put in less than 1, colon, and notice it starts entering things there. So there's my first piece, and I'm going to make this a little smaller again so I've got a little more room to type. Now I can also get more room to type by grabbing that and pulling that over. So there was my first part. Now my second part is that if x equals 1, I want this thing to be a 2. And then if x is greater than 1, I want the x squared plus 3 again. So a not equal to I could handle by just doing a less than and a greater than. And so I have that. I'm going to make this smaller again. I'm going to actually go over that a little bit so you can't really see it, but zoom out and look at what's happened here. This is kind of interesting. So we want to look at 1, and again, well, I have to kind of pull this out because I've already forgotten that fast. So at x equals 1, we want a 2, but everywhere else we want this other function. And so here's 1. Try to get there. 1.02, 1.04. Interesting how this works. So when I actually hit it, look down below there and you can see the 1, 2. Kind of strange how Desmos is working that way. So it didn't show up right away, but if I put my mouse over that, it showed it. But if I don't, it doesn't show that point. That's weird. Okay. Now I can get it to show that point simply by saying, okay, I want the point 1 and f of 1, and there, all of a sudden, there it is, right there. And now I could say label, and it says 1, 2, and you can go in here and change things about the label and label position, font size, all these kind of things. And in here I could change the label. So for instance, suppose I highlight that and do a Control C for copy, and I come down here and I do a Control V. Oh, that was weird. You didn't expect that, did you? Neither did I, really. But what these are the commands for LaTeX, a typesetting package, and we'll see tiny bits of some of that, kind of like we just did there. But so I could get rid of all that stuff that I don't want, and I could try labeling it like that, and there you go. You know, there's a nice label for that. It's very light in color, so again I could probably go here and say, well, let's label it black. Oh, it does everything in the same color, but now I can see it a bit better. And you know, so there though I have oops, done. You know, I was able to put that piecewise defined function in here, and with a little bit of extra work, get it to look more or less the way it's supposed to. Okay, but notice the technology for now is sort of hiding the fact that well, that's, I guess I'm just not coordinated enough here. So try to get here to 1. It's probably painful for you all to watch. Oh, I see. Okay. I was expecting it to do something up here, but no, all of a sudden down at the bottom there it showed me the 1, 2 thing. So it's not the greatest. That's enough of that. Okay. So it doesn't really show it, but since I know kind of what's going on and I saw the picture in the book and so forth, I can put that point in there. Okay, so I can make it show up if if I need to. All right, but again, so I could graph this and take a look and say, okay, they wanted the limit as x goes to 1, and as I look at this, well, yeah, there should be an open circle here at x equals 1 and the value y value of 4, but other than that, it doesn't matter that there's an open circle. As I look at the trend, everything heads toward 4, and so, oh, my limit here is 4. And let's see, I think if I limit, yeah, I don't think Desmos does limits. Okay, so we really don't have a nice way to do limits within Desmos per se, to just say limits, other than to look at it graphically or in a table. Okay, so that was number 18. I gotta get up here and look at let's see, 23 and 24. Oh, they want us to use these graphs, so there I really have to draw the picture, and now in like 25 and 26, it gives us piecewise functions again and says identify the values of c for which the limit as x goes to c exists. So if I put in 26, I'll have to make this wide again so I've got plenty of room. But here it says in 26, if x is less than 0, so I'll make that less than 0, it's just the function sine x. So I have that, and then if x is between 0 and pi with equalities, it's 1 minus cosine x. So, and we can put that in here, so I can say 0 is less than or equal to x is less than or equal to pi, and if I just type pi, it knows it's pi. And then what I want there is, what did I say, cosine, 1 minus cosine x, 1 minus cosine x. And then for x greater than pi, again, I just type pi there. Then x greater than pi, cosine of x. Okay, and now I'll make this smaller again and go looking for my graph. Get rid of that. Now, so what it looks like, now here's the thing with these piecewise functions. For the most part, if we have a nice function that we're used to, like x squared, e to the x, a polynomial, any of those that we've seen quite a bit over the last few years in math classes, we're going to have limits existing at all those values of x where it's defined. It's going to be fine. But as soon as we go to these piecewise functions, then we may have a problem at the boundaries. So here at 0, we might have a problem. But I am really sure below 0, no problem, because the sine of x, that's going to be fine. It's a nice, smooth function, and so as I follow that curve, I know exactly where I'm going. Then between 0 and pi for 1 minus cosine x, oh yeah, that's going to be fine. And that's this part in here. So anything in the middle of there, I know that's going to be fine. And then for x greater than pi, the cosine, that's going to be fine. So if I have a problem, it's going to be at 0 or pi. And so I can look at this graph, and I could make a table and so forth for things near 0, but it certainly looks like the limit here is 0. So that looks just fine. And then, though, out here at pi, right, there's a little bit more than 3, it looks pretty obvious that the limit doesn't exist here because we don't go to the same y value. So the left-hand limit exists, all right? We can follow that, and we're heading to 2. And the right-hand limit exists. We can follow this, and we're heading to -1. But since the left hand and right hand don't match up, then in 26 our limit does not exist. Okay, so we would have, if I added another note here, right, I could say, you know, the limit at pi does not exist. Okay, so I have that, but the limit at 0 does. You know, now they ask, their question was, well, where does the limit exist for this thing? And so my answer would be something like x strictly less than pi, so x strictly less than pi. That's so everything in there, and then everything out here is fine, so that's x greater than pi. And in both cases, notice I'm showing a dotted line here. That's nice when they shade things for these inequalities. But you see, I'm not including pi. So my answer would be the union of these two areas, or another way I could say it is x not equal to pi. Well, but I can't. I don't really have a good way of doing that in decimals, so I won't. Okay, so what was that? That was number 26, and the others, it's a little tougher to do with decimals. I mean, we could, but it's just easier to do by hand. And so I think for the basic homework out of this section, you know, this pretty much does it. So I will, you know, there I gave a few examples of some of the different homework problems. And like I say, I wish I could have gone back and forth between sketching some things and putting on decimals, but this does okay. So we'll call that good for this video and finish there.